Thank you, Lars, and good morning to everyone. Lars and I were chatting before, and I thank him for the invitation. We discussed that the last time SinterCast was here at ProHearings was in 2017. So I thought I would jump straight in with highlights and show you the progress since then. So here you can see a summary of key metrics. Our revenue since 2017 is up 81%. Our operating result up 73%. Earnings per share up 80%. Our dividend, our total dividend for the year is up exactly 100%. The cumulative dividend, as we get more confidence in the business and the business becomes more mature, and we've been more aggressive in the dividend. We've also changed to 2 dividends per year so we could lower the liquidity low point. So the cumulative dividend has increased from 99 million crowns to 282 million. And what we do is that SinterCast provides a technology to make engines cleaner. Yes? And so we save CO2 compared to the nearest alternative engine. Since 2017, our production has grown, so we're now able to make a bigger contribution. We were 2.1 million engines back in 2017. We finished last year at 3.5 million, and currently we're running at about 4 million, so we've actually doubled since 2017. And all of those engines on the road save CO2. So in 2017, we saved 4 million tons of CO2. And last year, we estimate that our engines contributed to the saving of 8 million tons. And cumulatively, over the years, since our production started in 1999, we estimate that we've now made 50 million tons of CO2 reduction. Yeah? So with that as a headline overview, let's back up. We'll introduce SinterCast and talk more about the development. So we are the industry leader for a new type of iron called compacted graphite iron. We don't actually manufacture the iron castings. We provide the control technology and the software to enable the foundries to produce this new material in a reliable way. CGI is only stable over a narrow range. So it was first identified in 1948, and people tried to make it over the years, but it wasn't until 1999, with the introduction of our technology, that the foundries were willing to commit to producing this material in high volume. Yeah? So our technology allows the foundries to produce more efficiently, less scrap, less waste, less energy consumption. And because CGI is stronger and stiffer than the normal iron, we can push engines harder, so higher pressure and higher temperature to get a more efficient combustion and therefore more power with less fuel consumption. And that, as we saw in the last overhead, leads to significant CO2 reductions. We started our production in 1999 with Audi. And we started our high volume series production in 2003 with Ford. We had our first full year profit in 2006. We gave our first dividend for the financial year 2010. And we have a track record of double-digit growth. So over the last 15 years, we've had 13% compounded annual growth. And we also look forward to continued double-digit growth in our future. And I'll look at that in more detail as we go through the presentation. This is a financial forum, so let's talk about how SinterCast makes money. So 90% of our revenue is from recurring revenue. Yeah? And the biggest source of that is a production fee. So every time that the foundry produces a casting with our technology, they make a payment to SinterCast. And we'll come back to that in more detail later. And we also have recurring revenue from the exclusive supply of our sampling consumables. And our current production is about, or our current use of the sampling consumable is about 200,000 cups per year. You see the sampling cup in the bottom left corner? It's about the size that you can fit into your hand. And let's put the 200,000 into perspective. If you do the math over the course of the year, that means one sample every 2.5 minutes. So during this presentation, we will make approximately 10 samples. We use one sample for each pot of iron. Yeah, so it means 10 pots of iron. And from each pot of iron, we make about 1,000 kilograms of casting. If you think about our average casting size, it means about 60 castings. So during this presentation, somewhere in the world, 60 castings will be made. They will all go into new vehicles. So what it means is that every 30 seconds, somewhere in the world, a new vehicle is rolling off of a manufacturing line with SinterCast inside. Yeah? So it's a mature technology, it's a proven technology, and it satisfies everyone's definition of high volume. We also have revenue from the sale of our equipment. We can also lease the equipment, but predominantly it's an upfront sale. And we have an annual software lease for the use of the software. So it's another source of recurring revenue. And finally, like all companies, we provide engineering support, we provide spare parts, we help foundries, particularly the newer foundries, to establish a robust process and to earn new business. Let's look at the production in more detail to have a visual reference. So this is a video from a foundry. You see the operator putting the sampling cup on our SAM, our sampling mechanism. And he takes a spoon of iron from that pot or ladle, and he lifts the little spoon of iron over our sampling cup for 2 or 3 seconds, and now he's finished. Yeah? So that golf ball sized amount of iron will sit in our sampling cup and solidify over about 3 minutes. And depending on the way that solidifies, we know how the rest of the iron in the ladle will solidify. And we have the opportunity, before they make the castings, to adjust or to correct the iron in the ladle and make sure that everything is in specification before the production. Again, putting that in perspective, the main ingredient that we add in the correction is magnesium. And over the course of last year, our average addition of magnesium was 35 grams per ton. So when we're adjusting and controlling the iron, we're controlling the 4th decimal point. Yeah? So we're really bringing a pharmaceutical level of process control and accuracy to this hostile foundry industry where the iron is at 1,450 degrees Celsius. Yeah? So it's really a precision measurement that has enabled the production of this new material. I mentioned earlier that we have a track record of double-digit growth. So this is now showing our series production over the last 15 years. And there are some ups and downs as ever in business. 2008-9, it was the economic crisis. And more recently, we had this sharp shock from COVID. But more or less, the growth has been a straight line. And again, if you do the math, over the last 15 years, we've had 13% compounded annual growth, and also last year, 13% year-on-year growth. And I'll come back and talk about 2023 a little bit later. And each time the foundry makes a casting, they also make this royalty or production fee payment to SinterCast. So as we have double-digit growth in the production, we also have double-digit growth in the revenue. And so you can see the similar trend. And I mentioned in the previous slides that we have a revenue from installations as well. And that explains some of the up and down in this plot. In some years, we have more revenue from installations. And typically, we'll have around 5 to 8 million crowns of installation revenue. In 2019, you can see the high bar. We had a record year with 20 million crowns. What I've done in this last graphic, I took the half-year results, which was 58 million in revenue. I doubled it to go to an annualized full-year revenue. And I divide that by the number of employees. So we have 29 employees in SinterCast. Again, we're not a manufacturing facility. We're a software house that provides control technology to the customers. So if you take our projected revenue, or doubling the revenue from the first half of the year, divide it by our 29 employees, we have revenue of 4 million crowns per employee. And with our 30% profit margin, we have a profit of approximately 0.9 million crowns. So it's a really strong and scalable business model and a very profitable business. And this is based on doubling the first half of the year, but already in the third quarter we've been very strong. So we're going to strongly beat these numbers before year end. We'll be well over 1 million crowns per employee of profit. We have an aggressive approach to the dividend. It's been our long-standing agreement with the shareholders that we transfer the operating result to them. So you also see this double-digit growth in the dividend. I mentioned earlier that we made our first dividend for the financial year 2010. So we now have 13 consecutive years of increasing the ordinary dividend. And again, we can do the math. It's a 22% compounded annual growth rate in the dividend. Since financial year 2010, we have given 111% of our operating result back to the shareholders, and the cumulative dividend, 282 million. Yeah? And so we will continue with that. That is our focus. We now have 13 years of consecutive growth in the ordinary dividend, and our goal is to extend that to 25 years. So with that as background, let's look at current year and also take the opportunity to look forward. At the end of last year, our production was about 3.5 million engine equivalents. That was our run rate through the autumn. As we came into this year, we were a bit disappointed that the production decreased. We know why. Two of our high volume programs were undergoing a model year changeover, so the production facilities were a little bit low while they made this design change. But in the first 4 months of the year, we averaged 3.3 million engine equivalents. And since then, with the model year changeover complete, the production has been really strong. We have had the long-standing target to reach 4 million. We did that for the first time in June with 4.1 million. And what's really interesting is that in July and August, we averaged 4.1 million, and that's through the summer shutdown period. Yeah? So July and August this year were 11% higher than July and August last year. So we're really on a strong run. Over the first 8 months of the year, we have 3.65 million year-to-date production rate. Last year in the first 8 months, we were 3.49, so we're up 4%. But the interesting fact is that last year, September through December, we ran at around 3.5. Yeah? And already today we're running above 4 million. So we're going to have a much stronger finish to the year. We will increase our year-on-year growth significantly above 4%. I don't quite know if we'll be able to reach double digit again this year, but I think we'll get close. So looking for a really strong finish to the year. Our series production, we are 51% commercial vehicle, 28% Super Duty pickup, 12% full-size pickup, 5% SUV and mid-size pickup, and 4% off-road, so construction, rail, marine, and agriculture. And what's really important to point out here is we don't do cars. SinterCast isn't cars. SinterCast is big stuff. There's a lot of discussion about electrification in the passenger vehicle market, but SinterCast isn't directly exposed to that. And let's take the opportunity of this slide to also discuss the market outlook. And we can go through them one by one. So for commercial vehicles, today in Europe, 96% of all commercial vehicles are diesel. In the United States, it's 99%. Of that balance, most of it is natural gas. Yes, there isn't an influx of electrification. Today, approximately 30% of all new commercial vehicles are produced with a CGI engine. Yeah? That will grow. By the end of this decade, most commercial vehicles will have CGI. So we see that the CGI penetration will grow from about 30% today to 80%. So even if there is some start of alternative technologies, the big story for SinterCast is that most of the diesel engines are converting to CGI. So we see continued strong growth in commercial vehicles through the end of this decade, and a really long production run, well beyond 2035. For Super Duty pickups, the OEMs in North America, Super Duty is only produced by Ford, General Motors, and Ram, who is Chrysler Stellantis. The presidents of those companies have clearly said that electrification doesn't work for these vehicles. When you're towing things, and most of the owners of Super Duty pickups tow a lot of things, whether it's a pleasure or work, and the driving range goes down terribly. So there isn't development on electrification, and we see again a really long run for this, well beyond 2035. For the Ford F-150, there are 5 different engine options in Ford F-150. Ours is the smallest and the lightest and the most fuel efficient, so it's logical that it will also have the longest lifeline. And interestingly, earlier this month, Ford has made our engine base engine on entry-level models. So we have always been the base engine on the mid-level models, but just recently now we are also base engine on the entry level, so that will be an increase in our volume. I'll come back and talk about that a little bit more detail later. Mid-size pickups, now we're talking about small parts of our business, but it's an interesting story. So we do the Ford Ranger, the Volkswagen Amarok. We also do some SUVs in this category. Ford and Volkswagen have a joint venture for building Ranger and Amarok. They both use the SinterCast engine. That has historically been built in the UK. They've just invested in a new manufacturing facility in Argentina and another manufacturing facility in South Africa. So these engines have a very high demand in Latin America, in Africa, and also in the developing Asia-Pacific region. Many people there need pickups for their business, but they can't use the big full-size pickups. So with the new manufacturing facilities, we see this going well beyond the 2030s. And in the rail and agriculture and marine, the duty cycle just doesn't fit electrification. This is the domain of diesel and will continue to be. We'll have a lot of growth in that sector, but just by the numbers, there aren't that many vehicles produced. So it will always be a smaller contribution, probably something around 5% of our volume. I mentioned that Ford has announced that our engine will now be base on entry-level models. So I went to the EPA website in the US, and you can type in any vehicle that's sold in the US, and they will provide the fuel economy statistics for that vehicle. So on the left, it's our engine, the 2.7 liter V6 petrol engine. We have displaced the 3.3 liter petrol engine as base, and you can see that we have 0.5 liters per 100 kilometers better fuel economy. Yeah. For the average Ford F-150 driver, that means 95 liters of fuel saved every year. When you use 1 liter of fuel, you make 2.5 kilograms of CO2. So if we multiply those 95 liters per year times the CO2 generation, we're making 300,000 of these engines per year, and they will be on the road, average lifetime 14 years. So over the course of the lifetime, it will save 1 million tons of CO2. And what I animate in the bottom of the slide now, just some statistics. So we have changed from a 3.3 liter base engine to a SinterCast 2.7 liter base engine. So we're 18% smaller. The horsepower is up by 12%, and the torque is up by 51%. Torque is what you drive. Torque is acceleration. Torque is pulling power. So this is the concrete example of SinterCast engines being smaller, stronger, and cleaner. Yeah? And In our production, all of our engines are pushed harder, and all of our engines are smaller and more fuel efficient and cleaner. So we can do that for each of our sectors. Scania is now using SinterCast for their newest engine, part of the Traton group. This engine will be used for Scania, MAN, Navistar, and Volkswagen. We said previously that that program will give us 1 million incremental engine equivalents per year when it's at full volume. We're in the ramp now. We're about 1/3 of the way through the ramp, so there's still a lot of upside in 2024 and 2025. But in their literature, they said that the new engine was 8% more fuel efficient than the engine that it replaced. Yeah, and we're a part of that because our stronger material allows them to push the engine harder. And if you go through the logic chain, average commercial vehicle driving 120,000 kilometers per year, consuming on average 27 liters per 100 kilometers. And so we can see how many liters are saved. We do the same math with 2.5 kilograms of CO2 per liter burned. We're currently producing between 175,000 and 200,000 commercial vehicles per year. And so it comes out that it's a saving of more than 1 million tons per year. On the Super Duty, it's a well-known statistic in America. There are 2 engine options, ours and one other. Ours uses 1,000 liters of fuel less per year for the average driver. And we're making 1,000 of those vehicles every day. This is part of this thing that every 30 seconds a new vehicle goes off a manufacturing line with the SinterCast engine. We're in such high volume, we're able to make large contributions. So if you do that 1,000 liters of saving and multiply it by 1,000 vehicles per day, again, it's a saving of 1 million tons of CO2 per year. We've already done the math on the F-150, where we're the smallest and the lightest and the most fuel efficient. But the interesting point is, this is just showing the saving this year, the year in which we make the vehicle. But those vehicles stay on the road for 10 to 20 years, and they make the same contribution every year throughout the life of the vehicle. So when you accumulate that, we estimate that our technology contributed to the saving of approximately 8 million tons of CO2 last year. And since the start of our production in 1999, a cumulative saving of 50 million tons. And let's put that into perspective as well. It's hard to visualize 50 million tons. Tesla, in their 2021 annual report, so this is a screenshot from their annual report, they say that in 2021, from the global fleet of vehicles, solar panels, and energy storage systems, battery systems, that they contributed to the avoidance of 8.4 million tons of CO2. And in 2022, as they produced more vehicles, they increased that number in their annual report to 13.4 million. So our contribution is in the same neighborhood as Tesla. What's different? We work on the big vehicles that consume a lot of fuel. And how do you make a big contribution? You work on the biggest part of the problem. That's where SinterCast is. I'd also like to put it in perspective with respect to the Swedish domestic transportation sector. So this is now from the Swedish EPA. And you can see in the plot on the right that we've ticked all of the different modes of transportation, everything from motorcycles to large locomotives. And you can see the total CO2 emitted from the domestic transport sector. Really good job of decreasing it in recent years, but in 2022, 13.6 million tons. Yeah? So in a couple of years, our technology will contribute to CO2 avoidance on the same level as the entire Swedish transportation sector. So it's a really significant contribution and something that we're really proud of. So with that, let's look forward a little bit. What's coming? What could come for SinterCast? We've already talked about the current sectors. Let's talk about new things. So last year, 2022, together with our largest foundry partner, Tupy in Brazil, we did a study of a current aluminum cylinder block. So this on the left is the aluminum engine. It's 3-cylinder. It's a 1-liter engine, so for small cars. It's from a European OEM. We use that as our test mule, and we tried to develop a CGI alternative that was the same weight. Yeah? And this is why so many people recently in the automotive sector have moved to aluminum, because it's lower density and therefore lighter. But if we can make CGI the same weight, there's a lot of advantages. So you can see in the aluminum version on the left, it's quite bulky. Yeah? And this is the thing about materials. If you have a weaker material, you have to use more of it. And as you use a stronger, if you want to hang a statue from the ceiling in your house, you can either use a 2-millimeter steel wire or a 4-millimeter aluminum wire. You just need more of it. Yeah? So in our CGI alternative, we have 54% less metal. Cast iron and steel have a lower energy consumption during their manufacturing. So in the manufacturing phase, we have 40% less CO2. Iron is better at damping vibration, so we have better NVH, noise, vibration, and harshness in the auto industry. The aluminum engine has to have an iron sleeve in the piston because the aluminum isn't so strong, so it will wear, and we don't need that, so we can have what we call a parent bore. We are lower cost than aluminum. And at the end of this program, we ran a 100-hour proof of concept bench test, everything successful. So together with Tupy, we are now introducing that to the passenger car industry. There are some developments, so it's really exciting to see when we get the first one. And it's ideally suited as a small engine to be the partner of a battery vehicle as a hybrid or as a range extender. And this is a rendering of that block and the development. So you can see in the bottom end, we've made it like a tunnel because a cylinder is a very strong shape geometrically. And we now add the bearing caps to the bottom and a ladder frame to keep the bearing caps from wiggling around at the bottom. And what's really unique in this engine is that rather than having metal, we've replaced the outer shell of the engine with plastic. Super low density, super low cost. Yeah? So it's a really interesting concept, and as I say, Tupy is doing a great job of promoting it, and we have some OEMs that are currently doing development programs. It's a little bit like a concept car in an auto show. It's not certain that all of the things in this will go into production, but we're showing our ideas, yeah? And some of those ideas will go into production. And on the commercial vehicle side, which I've said is our biggest production and our biggest growth opportunity, we're supporting that very heavily. Let's start on the right side initially with the picture. So this is an engine that was launched by MAN in Germany back in February. It's a hydrogen engine. So you'll see this on the road in the future, these hydrogen tanks behind the cab. And we have the exclusive supply for the cylinder head in that engine. So we've been the development partner and we're the exclusive partner going forward. So we're actively involved in this development of hydrogen engines. And on the left, it's a press release, again from our partner, Tupy in Brazil, together with Westport, the fuel injection specialists, and AVL, the engine design specialist. AVL designs most of the heavy-duty engines around the world, based in Austria. But this is for the development of a new high-efficiency hydrogen engine. And we're very pleased that there's a scientific advisory board to govern the development of this project. And I've been invited, SinterCast has been invited to participate on that board. So we're really intimately involved in the project. So in conclusion, we've had 9 consecutive quarters of year-on-year growth. It's clear third quarter of this year, super strong. That will go to 10. I'm sure that it will also go to 11 and 12. So that will be 3 years where every quarter is bigger than the same quarter of the previous year. Double-digit growth in our history and double-digit growth through 2030 as well. We believe strongly in high-volume production in our core sectors well beyond 2035. I didn't speak so much about it, but today our operating margin is around 30%. We have some structural changes. We will get that up above 40% in the next few years. so we'll become even more profitable as the volume increases. We have 13 years of consecutive increase in the ordinary dividend. Our goal is to achieve what's called dividend aristocrat status, to reach 25 consecutive years of increasing dividend. And with 50 million tons of cumulative CO2 savings today, as our volume ramps, we can go faster with that, and we target to reach 100 million before 2028. So it's a really good story with a really bright future, a great technology, and I hope you'll follow us going forward. Thank you.
Thank you, Steve. Thank you, SinterCast.
You're very welcome.
Let's just, get the big picture. We have, is it almost correct to say there are three ways to make an engine block? Regular iron, SinterCast, the CGI, and then aluminum. Or are there are also some other ways?
No. Those are the three. However, aluminum isn't applicable for large engines. It simply isn't strong enough. So by the time you get to about 5 liters, it's only the conventional iron or CGI. For passenger cars, aluminum is a viable alternative. But for the larger engines, what happens as the cylinder bore gets bigger, you talk about the increase in the diameter, but the area increases by the square. So the load goes up like this, and there comes a point very early when aluminum can't handle it. The other thing is that passenger cars, they tend to explode the fuel at around 170 bar of pressure, but commercial vehicles are 250 to 270. So you have bigger diameter, bigger pressure, and aluminum runs out at around 4 to 5 liters.
So, and you have a sweet spot when we look at CGI compared to aluminum. You have a sweet spot with the small 6 cylinders or the big 4 cylinders with at 2.5 liters. Your approach is the winning proposition.
Yeah, you have inline engines, like 3-cylinder and 4-cylinder, and you have V engines. And the difference is that in an inline engine, the pistons go up and down. The load path is very simple. In a V engine, they're going left and right, and the thing's pulling itself apart like a tug of war. And so you need much stronger materials in a V. So we've been very good in Vs for passenger cars. This new concept is an opportunity for us to get into inlines for passenger cars because we have the same weight and lower cost. But again, for the big engines, doesn't matter if they're inline or V, the pressure is so high that they need the stronger material.
And in the other end, like my old boat has a Penta 5.7 V8. That's regular iron, isn't it? And it's too big to be CGI or
no, not at all.
Or Penta think so.
No, not at all. We did Penta engines. We did the 11 liter and the 13 liter some years ago. I would say that 5.7 is a really strong area for us. These Super Duty engines that we make 1,000 per day, they're both 6.7 liters. One of them is a V8, the other is an inline 6. So I would say that's a matter of time. So sometime in the next 5 to 10 years, they will migrate to CGI as well. What happened to pressure in engines? Over the last 15 years or so, it kind of went from 200 bar, to 230 around 2013, to 250, and now the new engines are being designed at 275, 280. So this demand for cleaner has pushed the pressure up until the engines just aren't durable without CGI. You always have the option. You can make it in old iron, but you have to make it bigger and thicker and heavier, and at a point that isn't so market competitive. So you have the option. You can make it out of a weaker material. You just have to use more material.
So for my 5.7 V8, how much? I think that's regular iron.
It will be, yes, certainly.
If you made it from CGI, how much weight would I?
10 to 15%.
Okay, so that's like 35, 40 kilos.
Well, we save that weight on the cylinder block. So your 5.7 liter V8 block will probably be about 125 kilos. So we would save 10 to 15% of that, something like 12 to 15 kilos. depends a little bit. Those engines, I'm not going to say anything against Penta, but those older engines tend to be a little bit heavy. So it depends on where you start. If you get a slow old dog, you can take 15 to 20% out of it. If you start with a really modern engine, maybe you only take around 10%. But on average, 10 to 15 is the design target that the OEMs start with.
Okay. I should have cleared this with you in advance, but I know you have spare slides. You had one slide where you show competitiveness for electric, hydrogen, regular engines for different segments.
Yes.
Do you still have that?
Yes.
That was very interesting.
Well, this one. So we talked earlier about engines, diesel engines in diesel engines in Europe being 96% diesel. So I'll use the pointer, but here you see this 96% diesel. This is from ACEA, the Association of European Automobile Manufacturers. Alternative fuel, natural gas, petrol 0.1, and this would be electric. Yeah. So it is starting from a strong diesel denominator. This plot was published by the EPA in the United States, and they were forecasting what we will need in 2050 to meet net zero goals. And what's interesting in this, oops, sorry, I do the pointer. So here's long haul heavy duty where we work, and they try to determine what will it be. Will it be battery electric, hydrogen, or fuels like we have today, but e-fuels, net zero fuels? Yeah. And you can see that they lean toward liquid fuels in 2050. Everyone's talking about electrification by 2030 and by 2040. This is the United States government saying that in 2050 trucks will still use liquid fuels. Yeah? So I don't know how you can get more credible than that. These are the guys who write the rules.
Yeah. We have a question from the audience.
Not everyone use CGI. There must be one drawback, and I suppose it's a bit more expensive.
Yeah.
How much?
So two things that we have to counter. One is the cost, and the other is the machining. Because CGI is harder and stronger, it's more difficult to cut. So go from a raw casting to a so we have an on cost for the casting, and we have an on cost for the machining. I would say that that is approximately 25%. That's the on cost. How the foundries price it may be another thing. They may have some margin in that as well. And moving from current material to new material is perhaps an opportunity to increase margin, so it could be more than the raw on cost.
Looking at this slide then, one conclusion would be that going forward, hydrogen is a bigger competitor to SinterCast than electrification.
I don't believe in electrification for long-haul heavy-duty truck. It's far away. Generally, the industry doesn't believe in it, and here you can see that the EPA doesn't really believe in it. And there's a big difference between trucks. You know, you have small trucks that go in and out of the city. They may use today a 9-liter engine. And then you have large trucks that do long haul. They typically use a 13 or 15-liter engine. So that's where we work, those long haul ones. The ones that go in and out of the city, they may well become electrified. And then you get comments from OEMs like, within 10 years, 30% of our engines will be electric. Yeah, sure, that's the ones that are going in and out of the city. Yeah, the ones that we work on aren't in that discussion. Sorry, your question?
Well, looking
the hydrogen.
at this, hydrogen is a bigger competitor than electrification.
Right. And I showed the slide where we're working on hydrogen engines. The big question is, how will hydrogen be used? You know, there is fuel cell as one alternative, and there's as a fuel in an engine that looks a lot like a diesel engine today. It looks more than 95% like a diesel engine. Hydrogen will be corrosive to the rubber cables and so on, so you have to change those. But the base engine stays the same. So the real question is, how will the hydrogen be used? Will it be used in an engine, in which case SinterCast carries on as normal, or will it be used in a fuel cell? Fuel cell still has a lot of work. The other interesting thing is that the hydrogen quality for a fuel cell has to be much purer than for an internal combustion engine. And we certainly won't have pure hydrogen all over the world. So I think that this development work that we're doing with MAN and together with Tupi and Westport is us trying to show that the internal combustion engine is the best way to use hydrogen going forward. Absolutely growth opportunity for us.
We're running really low on time.
Yeah.
I want to make one point. When researching SinterCast, I went to Avanza. They have the PE numbers. They state you at 25.5, and then we emailed some about that. But if you look at the PE as ABG Sundal does it for the research for you, they do 2023, they take your actual Q1, Q2 and estimate Q3, that's almost done, and Q4, so they're pretty on target. They give 16.6. It makes a world of difference because 16.6 is cheap if we believe SinterCast's 10% growth target, but 25 is a bit pricey. But we talked about that before on ProHearings. It's a bit sad that Avanza sometimes are so off on PE. I just wanted to make that point. Do you have a quick
we see ourselves around 15, 16.
quick final one? We're running late.
You mentioned that eventually 80% of trucks would use CGI.
Yeah.
When do you think that will happen?
Sorry, I should have said in this decade. The next emissions legislation is due for 2027, so most of the OEMs are developing new engines for 2027. Traton Group Scania has already launched their so-called Euro 7 engine, that's with us, but others will follow. So it's a 27, 28 thing. Yeah, it's really near term. Can we do that? One more, quickie.
Just a very quick one.
Yeah.
What about buses? Intercity buses and buses long distance?
Yes, same engines, same engines. So the Traton engine, the 13-liter engine, that will go to, it's already in Scania and Navistar. MAN will start and ramp over the next 2 years, and then in 26 it goes to Volkswagen Truck and Bus.
Thank you. SinterCast. Thank you, Steve Dawson.
Thank you.